This video is going to cover chapter 6, sections 4, 5, and 6. So we start with section 4, which is called the triangle midsegment theorem. So in a triangle, the midsegment connects the midpoints of two sides of the triangle. Every triangle has 3 midsegments, which form the midsegment triangle. So in this specific triangle, you've got your triangle A, B, C, and if you were to identify the midpoints of those sides and connect them, each of these would be called a midsegment. That blue smaller triangle formed by the midsegments is called the midsegment triangle. The midsegment theorem says the segment containing the midpoints of the two sides of the triangle, or the midsegment, is parallel to the third side and half as long as that side. So because DE is the midsegment, it's parallel to AC and it's half its length. So we can say DE equals 1/2 AC, or we can say AC equals 2 times DE. Example 1 says triangles are used for strength in roof trusses. In the diagram, UV, which is here, and VW, which is here, are the midsegments of triangle R or SRT. Find UV and RS. So UV would be half the length of this third side, which means that UV is 45, and RS would be double the length of this segment, 57 times 2, or 114. Example 2 says, given R, S, and T are the midpoints of sides ABC, which means this would be congruent to this to this, and this to this. Complete the table. So A, and this is running left to right. A here says AB is 12, so this whole side is 12. BC is 14, and AC is 18, which would make ST half of 18, or 9. RT half of 12, or 6, and RS half of 14, or 7. And clear that off. Next up is B. BC is 15, AC is 22, and RT is 10. So AB would be double the 10, or 20. ST is half the 22, or 11. And RS is half the 15, or 7.5. And C, AB is 10. ST is 9. And RS is 7.8. So BC is double the 7.8, or 15.6. AC is double the 9, or 18. RT is half the 10, or 5. Example 3 says use triangle GHJ, where A, B, and C are the midpoints of the sides. If GH is 7x minus 1 and BC is 4x minus 3, what is GH? So the relationship between these two is that I can say 7x minus 1 equals 2 times 4x minus 3. Or I could have said 4x minus 3 equals 1/2 7x minus 1. To avoid the fractions, I can stick with the top one, distribute the 2. 7x minus 1 equals 8x minus 6. Subtract the 7x. And add the 6. X is 5, but it wants GH. So I'm going to plug it back in. 7 times 5 minus 1, or 34. All right, next up is 6.5, which is inequalities in one triangle. Theorem 6.9 says the triangle longer side theorem. And its name pretty much gives away what it says. If one side of a triangle is longer than another, then the angle opposite the longer side is larger than the angle opposite the shorter side. So in this diagram, we have two side lengths, a 10 and a 12. And what this says is the angle opposite the larger side, so angle C, would be bigger than the angle opposite the smaller side, or angle C the first time, would be greater than angle B, or vice versa. Angle B would be less than angle C. The triangle larger angle theorem now talks about the angles. If one angle of the triangle is larger than the other, then the side opposite the larger angle is longer than the side opposite the smaller angle. So from this triangle, on the last one, we don't know the length of the third side, but in this one, we could, if we wanted to put all of them in order, we could find the length of the measure of the third angle. But I'm really just comparing the two in front of us right now. The side opposite the larger angle, so AB, is going to be bigger than the side opposite the smaller angle, which would be CB. The triangle inequality theorem says the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So the sum of any two sides has to be bigger than the third side, which means if I have BC and AC, add those together, it has to be bigger than AB. If you look at the next one, AB and AC would have to be bigger than CB or BC. And the last one, AB and BC would have to be bigger than AC. Example 1, name the largest angle and the smallest angle. So largest is going to be opposite the longest side. Largest is angle C. Smallest is opposite the smallest side, angle B. B, name the longest and shortest side. So for this, I need to find that missing angle. If 46 plus 105 gives me 151, and I subtract that from 180, 29 is the remaining angle. So the longest side is opposite the largest angle, which would be IT or TI. And the shortest side would be opposite the shortest angle, which would be IJ, or the smallest angle. Example 2 says to complete with less than, equal to, or greater than. Given A, B, C is a right angle, and C is the 90 degrees. A and B can be interchangeable, but C has to be 90. C compares with angle A. C would be the biggest, so angle C would be bigger than angle A. Angle C would have blank to A and B. C would equal 90, and A and B have to add up to 90, so these are going to be equal. And AC has what relationship to AB? Since AB is opposite the largest angle, AB has to be bigger than AC, so AC is smaller than AB. Example 3 says the lengths of two sides of a triangle are 8 and 13. Then find the length of the third side. The length of the third must be greater than blank and less than blank. So this is a shortcut based on that triangle inequality theorem. And if it said the sum of any two sides has to be bigger than the length of the third side, this means that the length of the third side has to be greater than the difference between the other two, but less than the sum. So in this case, it has to be greater than the difference, 13 minus 8 is 5, but less than the sum, 8 plus 13 is 21. Example 4, is it possible for a triangle to have the sides with the lengths as indicated? So you're going to get given 3 side lengths. The easiest way to check these is add the smaller 2 and see if it's bigger than the third. If it is, that's yes. If it's not, it's no. So 6 plus 8 is 14, which is bigger than 10. So this is a yes. 3 plus 4 is 7. That is not bigger than 8. So this is no. 2.5 plus 4.1 is 6.6. That's bigger than 5.0. So this is yes. This time they're not in order, but you want to add the smaller 2. 4 plus 2 is 6, not bigger than 6. So this is no. And the last one, 6 plus 5 would be 11. 11 is bigger than 6, so this would be yes. All right, last up is section 6, and it's inequalities in 2 triangles. The first theorem is called the Hinge Theorem. And if you could picture it to be like a hinge, as you open something up and make it smaller, the opposite side is going to be bigger the further open it is, and smaller the closer those are. That's the idea behind the Hinge Theorem. It says if 2 sides of one triangle are congruent to 2 sides of another triangle, so you have to have 2 sides in each the same, and the included angle of the first is larger than the included angle of the second, then the third side of the first is longer than the third side of the second. So if we look at these, notice AB matches ED and AC matches EF. Those are your 2 congruent sides. And then angle A is the included angle, angle D is the included angle. So if angle A is bigger than angle D, it means these are spread further apart, which would make BC greater than EF. That's called your Hinge Theorem. The converse of the Hinge Theorem says the reverse. If 2 sides of one triangle are congruent to 2 sides of another, then the third side of the first is longer than the third side of the second, then the included angle of the first is larger than the included angle of the second. Again, this works like a hinge. So if you look at the diagram, you'd have to have 2 sides congruent, 2 pairs of sides. And this time we know the information about the side. If GH is bigger than KL, that means that these 2 are moved further apart, which makes this angle bigger. And I can say angle J is bigger than angle M. So when the conclusion is the angle relationship, it's the converse. When the conclusion is the side relationship, it's the original theorem. Example 1, given D is the midpoint of AC, so that tells me these 2 are congruent, and angle 1 is smaller than angle 2, bigger. What can you deduce? First of all, I need a second pair of sides, but this side is shared by both. And if that's the case, then the angle opposite the bigger one, or the side opposite the bigger one, which would be AB, is bigger than the side opposite the smaller one, which is BC, or BC is smaller than AB. And the reason we know this is the Hinge Theorem. Example 2 says complete with less than, greater than, or equal to. And it's that we're trying to find the relationship between 1 and 2. So I've got 2 congruent sides in the 4, or a pair of congruent sides, and then a pair of second congruent sides that would be shared. And then 1 is opposite the 4, and 3 is opposite the 2. So 4 is bigger, which means angle 1 is going to be bigger than angle 2. Last example, find the range values for K. So if I've got my 1 pair of congruent angles or sides on the outside, the shared side's the second one, and then the sides are the ones I know both angles of both about. 19 is bigger than 18, which means 5K minus 12 has to be less than 38. Because again, the 18 is smaller than the 19, so the 38 has to be bigger. So when I solve this, I get 5K, I add the 12, is less than 50, and K has to be less than 10. Now, sometimes that's all at once, is just that. The other times is I know that that angle has to be bigger than 0. So there's a lower bound as well. So I would also have to add to that side. So if I do that, I can do those both at the same time because it's a compound. I can add the 12. And I get 12 is less than 5K, which is less than 50. Divide everything by 5. And now I have a range. So 12 over 5 has to be less than K, which is less than 10. Or K has to be bigger than 2 2/5 and less than 10. That wraps up the video for 6-4, 6-5, and 6-6.